Hello, my name is Zach Lamb, and today I will be discussing SQL injection and how it relates to software security. Before we get started, we should discuss what SQL injection is. SQL injection is an attack vector that targets databases, and it does that through input fields in software or websites, inputting SQL code into that input that then can be used to manipulate databases on the back end. As we move forward today, we're going to be discussing three main areas concerning SQL injection. First, we'll be talking about the impacts and why it's such an important issue to be defended against today, as well as some of the historical uses that we've seen in the past for the attack vector. And then we're going to also be covering the mechanisms of SQL injection, talking about how it works and some of the different types of attacks. And finally, we'll be touching on the countermeasures and how you can protect your software against SQL injection attacks. In the modern computing world, we rely on data more than we ever have. Last year in 2020, humanity produced 64.2 zettabytes worth of data. Now that's a big number. Let's kind of break that down to something maybe we can understand. That is roughly 2 trillion 4K movies worth of data. And while we're producing all this data, we've also struggled to secure it. For example, in the period from 2009 to 2017, data breaches within the US medical industry have increased by 18 times. Also, in a study of 200 enterprises, it was found that 59% of those enterprises surveyed were unable to report applications or users that were accessing their databases. And 43% of those enterprises were also unaware of the number of databases even within their organization. So we've talked about databases and data, but I'd like to shift and focus specifically on SQL injection. Talk about the history and a few places where SQL injection has specifically been used to infiltrate databases. It's been around since 1998, and so it's not exactly new, but in 2009, Heartland Payment Systems experienced an attack. And during this SQL injection attack, 100 million credit cards were compromised and leaked to attackers. This impacted 650 financial institutions, and they lost over $300 million. Another example where SQL injection has been used to infiltrate databases was in 2012 when Ghost Shell, a group of hackers, attacked 53 different universities, including Harvard, Stanford, Cornell, all the big Ivy League schools. And in this attack, they leaked the names, usernames, password addresses, and phone numbers, all this personal information of 36,000 students and faculty. So SQL injection is not just a thing of the past. Right here is a vulnerability that is still relevant today. In 2019, Cisco reported on their website a vulnerability where their Cisco Unified Communications Manager was not properly validating SQL values. So how does SQL injection work? We've talked about this a little bit before, but I just want to go over it again. SQL injection is used to manipulate databases, and it does that through input fields, generally in web-based applications. Um, in those user input fields, the SQL injection utilizes escape characters to exit the input field and then begin to input SQL code to manipulate the database. Once those escape characters are used, the input is no longer sent where it is intended, but is instead sent to the SQL database. Now, SQL attacks can be classified in 4 different ways. First, injection through user input, injection through cookies, injection through server variables, or second order injections. We've already covered SQL injection through user input because this is the most common form of SQL injection. And we see here it's the can be done through form completion, and it involves that malicious input of escape characters that then sends SQL code back to the database. But user input isn't the only way to get SQL code back into a database. Um, you can also do that through browser cookies. Cookies are generally stored on a user's device, but if an attacker can gain access to those cookies and alter them, then they can build SQL queries into those cookies. And then when the user utilizes those cookies can go ahead and be put into the website and then alter the database. Another way that SQL injection can be accomplished is through server variables. Server variables include HTTP data, network headers, and some environmental header variables. And these variables are generally used to log data from the website to the databases. However, if those logs are not properly validated through, data types and things like that, then the attackers can forge variables that include SQL code that then, once again, can be sent back to manipulate the database. Now, this is probably the most complex of the attack types, second order injection. Here, the attacker will place malicious inputs using the escape characters and SQL queries to put data into the database, but they won't immediately use it. They'll come along with another attack later that exploits that data that was input into the database. And these are probably the most difficult to detect as well, because the attack takes place after the initial infection. So we've talked about why SQL injection is an important issue, and we've talked about how SQL injection works. So let's go ahead and move on to countermeasures and how. So SQL injection is difficult to defend against because of the wide range of attack vectors. And also because of that, no single countermeasure is going to work. Now this is not an exhaustive list, but here are a few steps that can be taken to protect your software during development from SQL injection. First, you need to identify all of the input sources in your software where the user is going to interact and input data into the system. Once you know where data is coming from, then you can start type checking all of those inputs, where if the data type does not match what's expected, then you can return errors to the user and restart that input process. And the final step that you can take to protect your software against SQL injection is positive pattern matching. Now, it's difficult for developers to imagine every single type of malicious input that an attacker can think up. And so it's easier to deny everything and then only authenticate what is expected in the input. So today we've discussed SQL injection. We talked about the impacts of SQL injection, and how it has affected databases through the past and how it's still relevant. And then we also talked about how SQL injection works, talking about escape keys and the SQL queries being input into user inputs, and also some of the other attack types, such as through cookies or second order injection. And then we talked about a few countermeasures that can be integrated into software development lifecycle to defend against SQL injection. Thank you.